Welcome to our video series. We will love to hear your ideas for future videos. Now, let's dive into the topic of the Generative Aesthetic Engine. In this page, we will cover the system architecture teardown of modern artificial intelligence in the world of art. We start by looking at a system log from October 2018, where a portrait of Edmond de Bellamy was auctioned at Christie's in New York. The deployment was considered successful because the bidding closed at over $400,000. However, the mentor note reminds us that while the system executed flawlessly and generated genuine awe, the machine itself felt absolutely nothing. This creates a fascinating tension between technical output and emotional experience. We are going to look under the hood to see why this technology breaks our legacy definition of art. This engine uses complex mathematical formulas to generate imagery, yet it lacks the internal life we usually associate with creators. As we begin this teardown, we must ask ourselves if an object can truly be art if no one was there to feel the process of its creation. The Generative Aesthetic Engine is a powerful tool, but its existence challenges the very foundation of human creativity and the value we place on the artist's signature. This exploration will take us through the technical and philosophical layers of how AI perceives and produces beauty. In our second slide, we examine the legacy architecture, which we call the Calloused Hand Protocol. For millennia, human skill was decoupled from output only through intense effort. We believed that effort was the evidence of consciousness. The dependency here is clear when we look at the physical struggle of historical figures like Michelangelo or the decades Glenn Gould spent at the Steinway piano. The relationship between that struggle and the final quality was the entire point of the artistic endeavor. In this legacy system, physical struggle was a primary input that led to the final output. However, the new AI deployment performs a surgical decoupling on this pipeline. It completely severs the link between effort and output. The mentor note explains that the calloused hands are now obsolete in the eyes of the machine. This shift is profound because it removes the labor as a metric of value. When we look at the pipes in our diagram, we see how practice and struggle used to flow directly into the output. Now, the machine bypasses these chambers entirely. This raises the question of what happens to art when the difficulty of making it is removed. If skill is no longer required to produce a masterpiece, we must find a new way to define the worth of the things we create. The calloused hand was a symbol of dedication, but the AI architecture operates on a different logic, where the result is instantaneous and effortless. Moving into the core algorithm, we find the averaging engine. This is where the magic of data processing happens. The system ingests massive amounts of internet training data, which you can see represented as a swarm of points entering a funnel. The execution phase maps text tokens to image distributions across billions of parameters. When a user provides a prompt, the machine does not create in the way a human does. Instead, it extracts. The logic is simple yet powerful. It finds the mathematical center of everything billions of human eyes have ever registered as a specific concept. For example, if you prompt the machine for a melancholy landscape, it looks for the centroid of every image labeled as melancholy in its database. The mentor note highlights that this is the statistical mean of human creativity. It is not an individual vision, but an aggregate of a billion visions. The centroid represents the most average, most recognizable version of an emotion or a scene. This explains why AI art often feels familiar, yet strangely distant. It is perfectly representative of the collective human record, but lacks the unique deviation that an individual artist might bring to the table. The funnel effectively narrows down infinite possibilities into a single, statistically probable point of beauty. It is an engine of extraction rather than one of original invention. The output layer is what we call the aesthetic mirage. Here, the system leverages the human visual cortex to its advantage. The model does not need to visit a museum to understand art history because it leverages centuries of compositional structure through pure data. It applies principles like the golden ratio, color theory, and the rule of thirds with machine reliability. The system behavior is perfectly average, hitting every perceptual register that humans find pleasing. The mentor note describes this as a perfect simulacrum. When you look at an AI-generated image, you are reaching for the water in a mirage. For a moment, Your brain lights up as if the image were real because it satisfies all the technical requirements of beauty that our eyes are trained to seek out. However, this is a vulnerability of the human mind. We are programmed to respond to certain patterns, and the AI is designed to exploit those patterns with absolute precision. It creates a vision that is technically beyond reproach, but conceptually hollow. The blue lines within the brain diagram show how the model's output triggers our neural pathways. It is a sophisticated illusion that uses our own definitions of aesthetics against us to create a sense of wonder. The mirage is beautiful, but it is important to remember that it is constructed from a calculated understanding of our own biological preferences. Now we reach the first critical failure point, which is the problem of flawless output. In our diagram, we see a comparison between a perfectly aligned grid and the expressive, chaotic lines of a masterpiece like the Starry Night. The warning zone here is that removing outliers also removes the signature of the artist. AI systems are designed to remove specific errors, but true art is often defined by what the artist got wrong in a way that no one else would. The flaw is the soul of the work. The mentor note suggests that AI is like the beauty of a wax museum. It is technically exact, but deeply wrong because it lacks the trace of a specific life under extreme duress. When Van Gogh painted the Starry Night in 1889, his mistakes were a reflection of his internal state. An AI would look at those brushstrokes as noise to be smoothed out or as a style to be replicated without the underlying pain. This error log shows that the trace of humanity is found in the deviation from the norm. By aiming for perfection, the AI misses the very thing that makes art meaningful to us. It produces a result that is visually stunning, but lacks the authentic struggle that defines human expression. The pursuit of the flawless output ends up creating something that feels sterile and disconnected from the reality of the human experience. Under the hood, we discover the intentionality gap. This slide illustrates the difference between the legacy protocol and the AI architecture. Historically, art has been defined as a handshake between two consciousnesses, a concept famously noted by Leo Tolstoy in 1897. In the legacy protocol, a lived experience passes from the artist to the viewer through a solid connection. In the AI architecture, however, that connection is broken. The AI has no biography, no grief, and no terror. The mentor note provides a striking analogy. AI output is like a perfectly formatted text message arriving from a phone number that does not exist. The signal arrived, but it was never actually sent by a conscious being. We see a missing dependency here, which is consciousness itself. The red zigzag lines represent the interference in the communication. While the viewer still brings their own lived experience to the image, there is no corresponding experience on the other side. This creates a vacuum of meaning. The artist box in the AI layer is empty because the machine is not an entity that can experience the world. It can simulate the appearance of a lived experience, but it cannot bridge the gap between two minds because it does not have a mind of its own. This gap is the fundamental difference between human art and machine generation. Our data structure deep dive looks at the concept of the empty signifier. In semiotics, a sign consists of a signifier and a signified. Here, the machine uses pointers without memory allocation. We see a signifier labeled as crying child. The machine can produce the pixels that correlate to distress because it has seen thousands of images of crying children. However, the logic points to a null reference. The machine has never been a child and has never lost anything. It does not understand the message it is signing because it does not speak the language of emotion. The mentor note explains that the sign works only because the viewer supplies the meaning from their own allocated memory. You see the image and feel sadness because you know what it means to be a child or to be in pain. The machine is simply moving data around to satisfy a prompt. The red box labeled null represents the void where the actual experience of the signified should be. This semiotic audit reveals that AI art is a collection of signals that trigger human responses without any underlying reality. It is a sophisticated form of mimicry that relies entirely on the observer to provide the depth that the creator lacks. The empty signifier is a powerful tool for communication, but it remains a hollow shell until a human consciousness interacts with it. In this edge case analysis, we look at the Duchamp exploit. This refers to the ready-made protocol established by Marcel Duchamp with his work titled Fountain in 1917. The logic here is that the role of the artist shifts from being a maker to being a chooser. When a person uses an AI, they are acting as a prompter, selecting from the machine's infinite outputs. The mentor note asks if AI is the ultimate Duchampian experiment. In this scenario, the human intervenes only as a chooser of the final result. However, there is a key difference in intentionality. Duchamp's irony was intentional because he was watching the reaction of the art world. In contrast, the AI's gaze is a mathematical void. It is perfectly indifferent to your response or the cultural context of the work. The prompter might feel like an artist, but the machine is just executing a bypass. The red arrow points to the computer, suggesting that the center of the creative act has moved. While the human still provides the initial spark and the final selection, the actual labor of creation is outsourced to an indifferent algorithm. This exploit challenges our understanding of authorship. If the artist is only a curator of machine-generated options, then the nature of creativity has changed from a generative process to a selective one. This transition has major implications for how we value the individual's contribution to a work of art. Next, we look at system democratization and the lowering of the API barrier. For thousands of years, visual expression was gatekept by inherited talent and expensive training. Now, the access level is global. The authorization required is simply imagination. A study from 2026 suggests that generative AI now outperforms the average human on standardized creativity tests. This means that a 14-year-old in Lagos or a 70-year-old in Japan can bypass technical skill entirely to produce professional quality visuals. The mentor note highlights that the barrier to entry has finally been removed. This is a massive shift in how art is produced across the world. The image shows a giant gate being lifted, allowing a stream of people to pass through into the world of visual expression. The metric of success is no longer how well you can draw or paint, but how well you can imagine. While this democratization is exciting, it also changes the landscape of the creative economy. When everyone can produce high-quality images, the value of those images might change. The focus shifts from the ability to execute an idea to the quality of the idea itself. This stage of the teardown shows us that AI is a powerful equalizer, giving a voice to those who previously lacked the means to express themselves visually. It turns imagination into the only currency that matters in the new creative world. The second critical failure point is the stagnation loop. This occurs when models begin training on their own outputs, a process known as the inbreeding of art. The warning zone here is that the long tail of aesthetic innovation is compressed into the mean. Art traditionally evolves through outliers, people who break the rules of movements like cubism, punk, jazz, or the avant-garde. These movements are represented by red crosses in our diagram because they are being filtered out by the averaging engine. AI simulates rule breaking but cannot truly commit to it because it is programmed to find the most probable result. The mentor note explains that AI is a machine for preventing art from being anything new. It keeps circling back to what has already been done, refining the average until everything looks the same. This Mobius strip of data creates a feedback loop where the unique and the radical are sacrificed for the sake of consistency and popularity. Without the influence of genuine outliers who are willing to be wrong or offensive, the creative well begins to run dry. The stagnation loop suggests that while AI can replicate existing styles perfectly, it might struggle to invent the next great art movement. This is a fatal error for a system that aims to represent the pinnacle of human creativity. True innovation requires the ability to step outside the funnel and create something that the data could never have predicted. To understand our current situation, we look at the historical fallback of the photography precedent. In 1840, Paul Delaroche famously declared that painting was dead upon seeing the first daguerreotype. However, the patch result was that painting was not dead but liberated. When cameras took over the role of visual record keeping, painters were freed to invent new styles like Impressionism and Cubism. They moved away from visual reality and toward abstraction and subjective experience. The mentor note suggests that AI is doing something similar today. By mechanically generating infinite beauty, AI will force human art to find what it does that the machine cannot. The diagram shows the path of visual reality being interrupted by the camera, leading to a vibrant explosion of new forms. we are at a similar crossroads now. If a machine can create a perfect landscape in seconds, artists must find a new purpose beyond technical perfection. This might lead to a new era of experimental art that focuses on the things a machine lacks, such as physical texture, personal narrative, and raw emotion. The photography precedent gives us hope that the rise of AI will not be the end of art, but rather the beginning of a new chapter where humans explore the boundaries of their own unique consciousness. The machine handles the mechanical generation of beauty, leaving the human to explore the depths of meaning. The problem of resource starvation leads to the aesthetic drought. This slide features a graph showing the inverse relationship between aesthetic volume and perceptual response. As the volume of AI-generated content increases exponentially, its scarcity value is destroyed. This is a warning zone where infinite abundance makes beauty feel like wallpaper. When a single model can produce 10,000 stunning images a second, the individual image loses its impact. The system response is a perceptual downregulation where the human visual cortex begins to tune out perfection. The mentor note describes AI-generated content as an invasive species. If something is everywhere, it is essentially nowhere. We see the red line of perceptual response crashing as the blue grid of aesthetic volume spikes upward. This suggests that we are reaching a point of saturation where we can no longer appreciate the beauty we are creating. The value of art has always been tied to its rarity and the effort required to produce it. In a world of infinite, effortless beauty, we might find ourselves longing for something simple, rare, and human. The aesthetic drought is not a lack of images, but a lack of meaning and connection. When perfection becomes the baseline, it no longer moves us. We are starving for something that feels real in a desert of manufactured excellence. The recommended integration for this crisis is the centaur architecture. This approach is borrowed from the world of chess engines and focuses on human-AI co-creativity. The logic is to combine the strengths of both parties. The AI supplies the generative abundance and handles the probabilistic space, while the human supplies the biography, judgment, and intentionality. In the diagram, we see a human brain and an AI chip working together inside a single cube. The workflow involves the machine generating a field of possibilities, represented by the grid, and the human making an intentional selection to find the path forward. The mentor note explains that we should not retreat from this technology. Instead, we should dwell in the uncanny space between human intention and machine output, finding the seam where the two meet. This hybrid approach allows us to use the power of the engine without losing our own voice. The centaur is not just a tool user, but a partner in the creative process. By maintaining control over the final selection and the underlying meaning, the human ensures that the work remains grounded in lived experience. This architecture represents the most honest response to the rise of generative systems. It acknowledges the machine's capabilities while asserting the necessity of the human spirit. It is a way to navigate the infinite sea of data without losing our sense of direction. Final output validation focuses on the premium on the imperfect. As AI saturates the world with flawless imagery, the error becomes the evidence we crave. We are seeing a market shift toward rising value in handicraft, live performance, acoustic breathing, and the visible brushstroke. These are things the machine cannot replicate because they are products of a physical, mortal existence. The new metric is that the flaw is the feature. The mentor note explains that imperfection is the undeniable proof that a mortal, struggling human being was present in the making of the work. We see a magnifying glass highlighting a rough brushstroke on a grid. That stroke is not perfect, but it is authentic. It represents a moment in time and a physical movement that an algorithm cannot truly simulate. In a world of digital perfection, we find ourselves drawn back to the tactile and the temporary. The premium on the imperfect is a defense mechanism against the digital flood. It allows us to reclaim the value of our own limitations. The flaws in our work are not signs of failure, but signatures of our humanity. By embracing our mistakes, we create a space that the AI cannot enter. This validation step reminds us that the most valuable things we create are often the ones that show the most evidence of our own struggle and our own mortality. Our final slide brings us to the mentor's closing note on execution versus meaning. We look at the distinction between aesthesis, which is how things look and is dominated by the machine, and poiesis, which is how things mean and remains the domain of the human. The diagram shows a robot arm painting alongside a human hand. The mentor note references the artwork titled Can't Help Myself, where a robot's mechanical actions made millions of people weep. The robot felt nothing, but the artists felt everything and used the machine's emptiness to express mortality. This is the ultimate lesson of our teardown. AI is the master of aesthetics, but it will never master meaning. The brush is still in our hands, and we must decide what we are going to paint with it. The machine can provide the tools and the templates, but only a human can provide the purpose. This brings us to the end of this video. We hope you found it informative and engaging. If you have any questions or suggestions, please leave them in the comments below. Don't forget to like, share, and subscribe for more content like this. See you in the next video.